Hi guys, in this video we're going to look at binomial theorem with the negative and fractional indices. So this is the advanced version of the binomial theorem, and I'm going to explain essentially the concept with the help of a problem. We have one exam question from here. I can hide the answer right now and let me focus on the question, right? 7-mark question. Okay, there I've got two parts, A and B. Okay, so let's see what the question has to say. It says that this is an expansion, an expression, which is exactly this, right? In ascending powers of x up to it is the term in x square, correct? Okay, so how do we solve this, right? First, you need to know what's a binomial theorem for this. And the formula for that is 1 plus x to the power n. When n is a rational number, can it be expressed as 1 plus n the power times x plus n minus 1 to factorial x square and so on and so forth. This formula is also given in the formula booklet. Just one note that the absolute value of x has to be less than 1. That's the condition for the advanced binomial theorem. Now let's see how we can use it to solve this question. Okay, I'm going to write down this bracket here as 1 plus ax to the power negative 1/2, right? Because there's a square root in denominator, which is the power half, in the numerator negative half, minus 1 minus x to the power half. And we know that this expansion has to look like 4bx plus bx squared. That is given in the problem. Now we're going to use this formula and write the expansion here. So it is 1. Okay, I'm writing expansion for the first bracket here. 1 plus, this is n times x, right? So n is negative 1/2. So it is negative 1/2. And x is ax. Plus the next term is going to be n, which is 1/2, negative 1/2, negative half minus 1, see, n minus 1. So negative half minus 1 will give you negative 3/2 divided by 2 factorial, 2 factorial and x square. X is ax, right? So it is ax the whole square. Well, I'm going to go on up to the term x square as per the problem. Minus, now I want to expand this, right? So it is 1 plus, okay, I'm going to take this as minus x, the second term. Half minus times minus x plus half minus 1, 2 factorial, and then this is minus x the whole square. Yeah. And then this is going to be equal to 4bx plus bx square. Okay, let's simplify this. I get 1. Okay, just be mindful of the signs very carefully. Minus a by 2x this term. Then this is minus plus. This 3 by 8 a square x square. Minus 1. There is a minus sign here that makes it minus 1. And this minus and that will make it plus x by 2 or half x. Then this minus over here, half minus 1 is negative 1/2. So that will be positive 1 by 8 x squared. That is equal to 4bx plus bx squared. I hope I did all the signs correct. So negative 1 and positive 1 will cancel out. This will be positive. Just checking the signs once again, guys. Yeah, it looks good. Okay, so now what I'll do is I'll club the terms of x together. So it is negative a by 2 plus 1 by 2x. This is the x terms. And with x square, you have these two terms here. So it is 3a square by 8 plus 1 by 8 x square, right? That's the x square term, which is 4bx plus bx square. Okay, so once you get to this level, you say that, well, these two expressions are exactly equal. So this has to be same as that. Okay. and this has to be same as this. So what do I get? I get negative a plus 1 by 2, which is this here, is same as 4b, which is then 8b is equal to negative a plus 1. That's the value for 8b I got. And when I compare the second one, I'm going to get 3a squared plus 1 over 8. The second bracket, right, is same as this, no? Is equal to b. So you get 3a squared plus 1 is equal to 8b. And well, you know what 8b is, right? So you can plug in, let's say 8b here. So we plug that in here. So you get 3a squared plus 1 is equal to minus a plus 1. Correct? And then you can cancel out 1. And then you get 3a squared plus a is equal to 0. So you can factor out a, you get 3a plus 1 is equal to 0. Then that gives you a is equal to 0 or a is equal to negative 1 by 3. So a, if you see condition that a can't be 0, right? That's given in the problem. So a is equal to 0 is discarded, and so you have the value of a as negative 1 over 3. So the value of a is negative 1 over 3. That's the answer for a. And you plug that back into the equation. So since we have 8b is equal to negative a plus 1, and a is negative 1 by 3, so it'll become 1 by 3 plus 1, which is 3 times 1 is 3, 4 by 3. 8b is equal to 4 by 3. So b is equal to, well, you can just divide by 8. 4, 8 times 3. So b is equal to 1 by 6. I hope I'm right about this. So that's how we find the values of a and b. A is equal to negative 1 by 3 and b is equal to 1 by 6. I'm going to check the answer real quick. I hope I'm correct. Okay, so go back, see the answer. Yes, a is equal to negative 1 by 3, b is equal to 6. And that's how you solve the question, right? And once you do that, the next part, the B part, says state the restriction. What is the restriction must be placed on X for this expansion to be valid? Now, please remember, guys, that whenever you do 1 plus x to the power n, and the expansion is nx, n minus 1 to factorial x square, so on, there is a very important condition which says the absolute value of x has to be less than 1. And this condition has to be true. And while we used it for ax and x, like we wrote 1 plus ax to the power negative half for this one, and 1 minus x to the power half for this one, since we use this expansion which has this condition, the x we have here, like ax, the absolute value of ax has to be less than 1. That is, absolute value of x is less than 1. And only then you can use the expansion that we used. I hope you understood this. If you want to see any part, you can go back and go back to the video and see it. One other question on advanced binomial theorem in the exam. I hope you understood this. You can visit leadib.com for more such questions. My name is Yogesh Prabhu, and I see you in the next video.